Now we're going to continue with the chapter 3. We're going to finish it up by looking at writing equations of lines. So on 34, you're given the point and a slope. On 35 and 36, you're given 2 points. And then 37 deals with the parallel and perpendicular issue. Okay. So when you see the directions and you see that they say write an equation or find an equation, if you see that, if it says like find an equation of the line, and you see that word equation, then that means you need to go on. What we did is we used the point slope formula, which will be on your formula sheet. Okay. It's designed for a problem like 34. So write down the formula. And then you're going to plug in the slope. And you're going to plug in your ordered pair here. This is like x1, y1. So y minus the y1 equals -8 times x minus the x1. All right, then at that point, you're just needing to clean this up to get it into the form they want. And I didn't write this, but we like the final answer in slope-intercept form if possible. So we'll distribute, which will give us -8x, and then don't mess up. Negative times a negative is positive 24. Okay, and then got to get the y, so I'm going to add 5 to both sides. So my y would equal -8x plus 29. And that's what they want. It's the equation of the line in slope-intercept form that fits those given conditions. Okay? So a good double check is, yeah, it has the slope it's supposed to have. And look and see if you plugged in 5 for the y and 3 for the x, would that be equal? 5 would equal -24 plus 29. Yep, it fits this condition and this condition. So I know I got it. All right, now what's happening on 35 and 36 is you just have to find the slope first. They didn't give you the slope. So first thing you're going to do on that, you're going to use that y minus y1. So go ahead and write that down because you know you need that. Then think about how you need the slope. You don't have it. So the first thing you're going to do is work on finding that. So you're going to take your points, right? And you're going to wind up thinking about that formula, subtract the y coordinates, then in the same order, subtract the x coordinates. Make sure the y's are on top. Make sure you subtract it in the same order. And if you have the issue of like 4 minus a -3, make sure you think of it correctly. That would be 7, 4 plus 3. And then 8 minus 6, that's going to give you 2. That's your slope. Now, you've got your slope, right? You got your slope. And you've got 2 points. You have more than you need, so you just pick one of them. And I would pick this one because the coordinates are positive, so I'd be less likely to make a mistake. Okay? So that would be y minus 4, because 4 is the y coordinate, equals the slope, which is 7/2, and then x minus the 8, because 8 is the x coordinate. Okay? So yes, it has fractions, but you've got a calculator that'll do it. So that's 7/2 x. And then 7/2 times -8, do it on your calculator. That's going to be minus 28. And then you want to get this so y is by itself. So the last step would be to add 4. And you'd get y equals 7/2 x minus 24. Now let me show you what would happen if I had used the other point in there. Okay, what if I had used like if it at this spot right here I had used the other ordered pair? I would have had to do y minus -3 equals 7/2 x minus 6. Now this is your answer, so you wouldn't do both of these. This is the answer. Okay, I'm just saying if you had happened to pick the other one, I want you to see what would happen. Biggest mistake would happen with that minus a -3, because that's really y plus 3. Do that step before you try to move things around. Then go ahead and distribute. And that's going to be 7/2 x, and that would be minus 21. Okay. Then get the y by itself by subtracting 3 from both sides. So that would be y equals, y equals 7/2 x minus 24. Okay, same thing. Do you see it? So it wouldn't have mattered, but this one would have been a little harder because people mess that up. If you don't rewrite that as y plus 3, then sometimes you don't subtract the right thing from both sides. So be careful there. All right, and then let's see what happens here. So I'm thinking I need an equation. So I'm thinking about that same formula, but then when I go to find slope on this one, watch what happens. If I do 1 minus 9, when I come back and do 10 minus 10, I get a 0 in the denominator. Now you might have gotten a -8 or a +8 on top, depending on the order in which you subtracted. But this is -8 divided by 0. This is the one that gives you an error on your calculator. This one is undefined. We can't plug in anything for slope. We can't use that formula. So how in the world? Don't make the mistake of thinking the equation's undefined, because it's not. Here would be the point 10,9. Here would be the point 10,1. This is the line that we want. We do it in red. This is the line I want. I want the equation of that. Okay. This is the x. This is the y. I want this red line, and I'm over here at 10, up 1, at 10. This is 10,9. This is 10,1. See how I'm always over to the right 10? See how all the x's on that line are going to be 10? The equation for this, I'll do it in red, is x equals 10. So it's one of those special cases. You really got to draw it and think about it. Okay? All right, and then one last problem I want to work has to do with the parallel and perpendicular. So this is number 37. You need the line that goes through the point 3,8. You want the equation, it says. The directions say find the equation of the line that goes through that point and is perpendicular to this line. -3x plus 4y equals -23. Okay. All right, so I'm thinking when I see that, I'm going to eventually use this equation. I'm kind of just planning out my plan of attack. I have the ordered pair that I can plug in. Here it is. But I need the slope, okay? And that's what all of that is going to help me find, is the slope. When I see the word perpendicular, I know my slopes are negative reciprocals. And then when I have an equation here given to me, I can find the slope of it, but I need to get the y by itself. The slope is not going to be -3 because I don't have it in slope-intercept form with the y by itself. So here's how you begin. You start by taking that equation and rearranging it and getting the y by itself. So I'm going to, let me show you what I did. I added It's getting a little slow. I think I'm bogging down my memory on this. Added 3x to both sides. Okay. Then I want to get rid of the 4. So I'm going to divide by 4 everywhere. And that gives me 3/4 x minus 23/4. I don't care about the 23/4 really. I did all of this because I'm trying to figure out the slope of this line. So this line here, the slope is 3/4. My line is perpendicular. So it has to be flipped over. And since 3/4 was positive, this one has to be negative. Okay, then what you got to do is you got to let that go. You're done with it. And you're going to take the slope of -4/3 and the point you were given, and you're going to work on plugging it in to the y minus y1. So y minus 8 equals the slope times x minus -3. Okay. So before you distribute, take care of this minus and negative. Okay. Now distribute. So this became positive x plus 3. Now distribute. And we wind up with -4/3 x, and then a negative times a positive would be negative. 4/3 times 3 would be 4. So -4/3 x minus 4 is what we have there. Okay. And then on the left, we have y minus 8. So we need to add 8 to both sides to get the y by itself. And we wind up with y equals -4/3 x plus 4. Okay. Wanted that whole thing in red. It was just being delayed. Oh well, here we go. It's a little glitchy right now. It's just getting worn out. So y equals -4/3 x plus 4. That would be your final equation. Okay. So that one you might need to stop and watch a couple of times and then try it a couple of times. It's got a kind of a lengthy process. It makes sense, but you have to really work to make sense of it, not just kind of try to copy an example. Okay, so work hard on that one.